All right, welcome back. So this is our last topic here in Unit 12, the cross product of two vectors. So our last type of multiplication of vectors. So unlike the dot product, cross product of two vectors will always yield a vector, not a scalar quantity. And this is because we are doing a 3 by 3 matrix determinant to do the cross product of vector A cross B. Order does matter, so make sure you're setting up the correct A cross B. The top row of your 3 by 3 will be I, J, and K. Middle row is the components of A, so A1, A2, A3. Components of B for the last row, B1, B2, B3. So we had only talked about using the calculator for a 3 by 3 determinant, so I'm going to show you one way of finding a 3 by 3 determinant by hand. We can't fill in I, J, and K into our calculator and have it give us a meaningful answer. So we want to find the cross product of U and V here, so U cross V. So we would have set up our 3 by 3 determinant. It's I, J, K, and then 3, -2, -1, -3, 3, 1. Now the way this is going to work is we're going to find some determinants, 2 by 2 determinants, 3 of them in fact, using I, J, and K. Now the way we find these 2 by 2 determinants is, so the determinant that's going to multiply with I, if we ignore the I row, we ignore the I column, all that's left is 2, -1, 3, 1. So that's our 2 by 2 determinants. For J, we're going to ignore the J column and J row, so it's going to leave us 3, -1, -3, 1. And notice, to do this 3 by 3 determinants, that is the middle matrix with the J. You're going to always subtract that determinant value. Always. So it's always a positive for the I, negative for the J, and then positive for the K. K, same process. We're going to ignore the K row and K column. So it's going to be 3, -2, -3, 3. So again, your 2 by 2 determinants is a very simple cross product. So 2 times 1 minus 3 times -1. That's all going to multiply by I. And then minus 3 times 1 minus -3 times -1, all going to multiply by J. And then 3 times 3 minus -3 times -2, all going to multiply by K. So 2 times 1 minus 3 times -1 is going to give us a value of, it's a -2 right there. It's a good thing I caught that. It's going to give us a -5 there, so it's a -5I. And then 3 times 1 minus 3 times -1 there is going to give us a +6, but it's minus that, so it's a negative then, so -6J. And then 3 times 3 minus -3 times -2 is going to give us a +3, so it's +3K. So we can also then write that as the component form, -5, -6, 3. Either one is fine. All right. So again, really can't use our calculator here to find our 3 by 3 determinant because the calculator will not properly identify I, J, and K, at least your typical 84. The Inspire can probably figure it out because it can handle algebraic variables. The 84 cannot handle 3 different algebraic variables like that, so we're not going to go through that process. Let's do another one. This one's again in component form. So we're doing our U cross V. So again, we have our I, J, and K in the top row, and then 4, 2, -1. 5, 1, 4 in the second and third rows. So again, ignoring the I row and I column, we would have 2, -1, 1, 4 times I, minus, ignoring the J row and J column, 4, -1, 5, 4. And then for K, again, ignoring the K row and K column, you'd have 4, 2, 5, 1, and then K. So again, we would have 2 times 4, minus 1 times -1, that's for the I components, and then minus 4 times 4, minus 5 times -1, that's the J components, and then we would have 4 times 1, and then minus 5 times 2, that's our K components. So we should be getting a 9I, a -21J, and a -6K, which again, you write in the component form 9, -2, -6. We want to do that instead. All right, so that's our cross product. Just doing a 3 by 3 determinant by hand. There are other ways to do the 3 by 3 determinants. This is the best way to do it, though, in terms of the I, J's, and K's, not get all sorts of screwy. There are other ways, but this just works out much better. Now, there's two applications for these cross products. Turns out, if we create a parallelogram, which is what typically happens when you have two vectors, u and v, create a parallelogram and draw it together, if you do their cross product, that turns out to be the area of the parallelogram, simply being the magnitude of that cross product right there. So here's our u and v once again. So we're going to find our cross product, u cross v. So once again, we fill in our I, j, and k in that top row. 2, 4, negative 3, 1, negative 5, 3. So when we ignore our I row and I column, we get 4, negative 3, negative 5, 3 times the I. Minus when we ignore our j row and j column, we have 2, negative 3, 1, 3. That's our j. And then finally, we ignore our k column and k row. We would have our 2, 4, 1, negative 5 times our k. I'm not going to go through and write out each determinant again. You should hopefully be getting more comfortable, reviewed than comfortable with the 2x2 determinants. So you should be getting this value right here to be a negative 3i, and then a negative 9j, and then a negative 14k. Which means w, which is what that is, finding the magnitude of w is going to be the square root of negative 3 squared plus negative 9 squared plus negative 14 squared, which comes out to be the square root of 286. So our area of this particular parallelogram is the square root of 286, which is approximately 16.912 units squared. Now, if they gave us, this thing was the dimensions of inches, then it'd be inches squared or feet squared or whatever the units happen to be. But again, we're just working through our 2x2 determinant setups based on the 3x3 determinants. Have to do it by hand because the I, J, and K components can't be put into the calculator. This last one, though, the volume of a parallelogram, three-dimensional parallelogram. I'll work on pronouncing that for you guys in class. We have to find a triple scalar product of this. So rather than using the top row as I, J's, and K's, the top row is this third vector t. So we can find just a normal numerical 3x3 determinant, which I'll show you by hand how that would work with our new method, and then you can confirm that on your calculator. So finding this particular volume is t tot u cross v. So we set it up so we would have 4, negative 2, negative 2, 2, 4, negative 3, 1, negative 5, 3. So ignoring the row, do the base off the top, ignoring the 4 row and column, we'd have 4, negative 3, negative 5, 3, and we multiply by that 4. And then minus, so we ignore the negative 2 in the middle, row and column, we'd have 2, negative 3, 1, and 3, multiplied by that negative 2. And then plus, ignoring the last negative 2 up top, it's row and column, we'd have 2, 4, 1, negative 5 times that negative 2. So for the determinant for that 4 times, so we'd have 4 times 3 minus negative 5 times negative 3 times 4. And then minus, we would have our 2 times 3 minus 1 times negative 3 times negative 2. And then plus, we'd have our 2 times negative 5 minus 1 times 4 times negative 2. So we would ultimately get, so we would have 12 minus 15, so negative 3 times 4, minus, so we'd have 6 minus a negative 3, so that'd be a 9, times negative 2, and then plus 2 times negative 5 is negative 10, and then 1 times 4 is 4, so that'd be a negative 14, times negative 2, we would get negative 12 plus 18 plus a 28, which is equal to 34. And if you do your 3x3 determinant in your calculator, since this now has all numbers and we can do that, and I would recommend that since it's obviously much quicker, you would also get 34. All right, so those are our cross products, and that's how they're used. Areas for a parallelogram and the volume of the three-dimensional parallelogram. Just make sure you're comfortable with the by-hand process for the regular cross product and the area, since you need to have the I, J, and K in that top row. And again, the calculator cannot help you. All right, so that's it for vectors. That's it for Unit 12. As always, appreciate you guys watching, and I'll see you next time.